notice that on a bunch of my other videos I actually built the SMAC booster cell, and as we see here, thanks to the SMAC for throwing that information out. Again, we have a picture of the cell and the sight tube. We also see that the gas that is produced, and this is the one with the stainless steel switch plates, and actually the gas is produced, goes out through the tube, goes through the one-way check valve, goes up through the bubbler, and then out the HHO gas or hydroxy out to your vehicle engine. I had a real good time building that. Definitely a good hobby. Very interesting, learned a lot of stuff. But the next thing that I'm concerned about is how do I install this in the vehicle, in my 97 Ford Ranger truck, little 4-cylinder. And so what I've done is I've been reading over installation diagrams and forums and posts and things like that. And I want to show you, basically share this information, what I found, and maybe some other people can help me out as well. And so anyway, now, like I said, the next step, since I built my SMAC booster cell, and probably for lots of other people out there, they built some kind of hydrogen cell or HHO cell, and they're really wondering on, well, what is the wiring diagram? How am I going to put this in my vehicle, and what wires go where? Well, I wanted to come up with a basic HHO cell wiring diagram from the stuff that I found from blogs and information and other people here on YouTube, and to really kind of hopefully put some information out to help others. Basically, we all have some type of HHO cell, whether it's a SMAC booster or a series cell or even a dry cell, that produces gas, HHO or hydroxy gas, and it goes out to a bubbler, a flash arrestor, and it goes into the intake of our engine or the air box. Well, we know that we have to have positive 12 volts going to our system. We also know that that comes from a 12-volt battery. And we also have the negative line, going to our cell. Now, if we need to have something in between this line, and the first thing that we're probably going to need is a circuit breaker or a 30 amp inline fuse. I've seen both. You get a 30 amp circuit breaker. I haven't seen them, but that's what I've read on some articles and stuff like that. And it seems to me that a circuit breaker would, I think that would work a lot better, because you could reset that manually, and with a 30 amp fuse it would just blow out. So again, but the option is there. Now we also need something else, because we need to have some type of switch to turn on our HHO cell. And again, this cell is for vehicles that do not have an O2 sensor. If we had it just going straight, we'd have no way of turning it on or off. So we need a 12 volt 70 amp relay, or some type of relay. I've ran across 2 other articles that talked about putting a 12 volt 70 amp relay in here to help put our switch in. Now we have a ground that's here, and that goes to the vehicle chassis. For those of you that don't know, it doesn't connect up to the negative of our battery. It just goes to the vehicle chassis. We have, again, a 12 volt DC power going to an on-off DC switch. For those of you that don't know, there are different switches. There's ones for AC power, and there's ones for DC power. And this switch can be installed on the dashboard of your vehicle, or it can just be put into a box and set somewhere inside the cab of your vehicle. If you want to go, now this is the basic wiring installation, to kind of get an idea of what is required for the basics of wiring your HHO cell into your vehicle. Now, if you wanted to go past the basics here, you could actually take another power and continue that 12 volt power line to your ignition. So that way, when you put your key in the ignition and you turn your vehicle on, it will supply power through the on-off switch, through the relay, and it would actually turn on your HHO cell when you started your vehicle. You can have, I would probably, myself, I would want to have an on-off switch as well, so that way, in case I did not want to run the HHO cell, I could turn it off, or if I was doing maintenance or whatever, I would have that flexibility. So that's basically the cell wiring diagram for vehicles that do not have an O2 sensor. Now, for those vehicles that do have an O2 or an oxygen sensor, we're going to need some type of EFI device, and EFI stands for Electronic Fuel Injection Enhancer. And again, we just went over, we have our cell, we have our battery in the vehicle, the circuit breaker or the inline fuse, a relay and the on-off switch and the ignition. But we need something else here because of the HHO that's produced by our cell. That goes to our vehicle, and the O2 sensor picks up that extra oxygen, and seeing that it's a leaner mix, what the onboard vehicle computer will do will take that oxygen sensor reading, and the computer will adjust the amount of fuel that goes into our engine, if I understand it correctly. And so that way it would negate any of the gains that we could get with our hydroxy gas. So basically we have an EFI device, and there's different ones out there. I'm just showing the basics here, and we run a 12-volt line into the EFI device, and it's also grounded to the vehicle chassis. And for a single O2 sensor vehicle, where there's only one oxygen sensor, usually you'd have one line, from what I've been reading, that goes to the oxygen sensor. And then it goes to the EFI, and then there's a line that goes out to the vehicle computer. And basically what happens is that the hydroxy gas that's produced by our cell would go into the engine, and the oxygen sensor would sense that extra oxygen from our cell, and the EFI would kind of bump up the electrical signal going to the computer to actually kind of fool and trick it to thinking that it's running at the correct voltage that it's supposed to. And I think it's like, if I remember correctly, it's like a 14.7 to 1 ratio. And it uses like milliamps, or correction, millivolts. And the EFI device you can raise or lower that setting to lean it out. And so actually the computer, the onboard vehicle computer, will actually think that it's getting the correct mixture, but actually the EFI device is actually tricking it so we can better use our hydroxy gas. So anyway, that's the basic cell wiring diagram with an EFI device. Okay, so there we go. The basic cell wiring diagrams for a vehicle that does not have a O2 sensor. And again, the second part is with a single oxygen sensor, O2 sensor, and kind of give you an idea of exactly how things work under the hood. And again, like I said, I got no clue because I'm not a mechanic. I can blow stuff up. I've had a lot of experience doing that, but I don't have any experience with mechanical or auto-mechanical stuff. So again, this is a learning experience for me, and I hope it'll clarify and kind of make it not so scary of what's underneath the hood of our vehicles. And again, the whole purpose is to share information and to get our HHO cells into our vehicles, and pass on this information to others so we can don't have to pay so much at the pump. If there's any corrections or anything, get in touch with me. Let me know. If I'm putting out some wrong stuff, let me know, and we can change it up and help everybody. So. But that's about it. And I'm hoping if there's some smart people out there who know like how to put a pulse width modulator into that second diagram and where that would go and how you would hook that up, contact me at almosthydrogen@gmail.com, and that way you can contact me and let me know, and I can do another video and how to put in a pulse width modulator to help in our not letting our systems overheat, and pass that information along as well. So anyway, that's it. So have a good one. Peace, and we'll catch you later.